In this lecture, we'll see what is the definition of machine learning and what are different applications of the machine learning. So coming to definition of the machine learning, so machine learning is it enables a machine to automatically learn from the data and improve the performance from an experience and predict the new things without explicit programming. Simply, it is called as a machine learning. That means machine is going to automatically learn from the data, improve the performance from an experience, and predict the things without explicit programming is called as a machine learning. So here, for the machine learning programming, machine learning algorithm, we are providing the data, training data. The data is called as training data. So from the training data, the machine is going to learn what are the things, what are the features of the data. So based on that, corresponding model, we are going to generate a model. That model is called as a mathematical model. And from that, from that mathematical model, we are going to predict the new things. Simply, it is called as a machine learning. So coming to the traditional programming, for the computer, we have to provide the data and corresponding model. From that model, automatically we can predict the results. This is called as a traditional programming. Coming to machine learning programming, first of all here we have two things are there, two steps are there. One is learning and the second one is prediction. So in the learning thing, the first of all the computer learns get the simple data and corresponding expected output data as input for the computer. From that computer we can generate a model. So from that, okay, so this is called as a trained model. This is called as a mathematical model for the data. So for this model, and next once again we have for the computer, we are providing the new data and corresponding model as the input for your computer. From that, we can predict the new things. This is the called as a machine learning. Now, in simple words, we can find you can feed that training data to we can feed the training data to the machine learning algorithm. That means we are for the machine learning the data is very important. So here for the machine learning algorithm, we are providing the some training data. So from this algorithm, we'll produce a mathematical model, and with the help of the mathematical model, the machine will make a prediction and take a decision without being explicitly programming. Simply, it is called as a machine learning programming. During the training data, it, the more machine will work with it, the more it will get the experience, and the more efficient results is produced. That means if you train the model more efficiently, more time, so automatically we are going to get the results also efficient result. Okay, this is the machine learning. So for example, in a driverless car, the training data is fed to algorithm like how to drive a car on the highways, busy and narrow street with factors like speed limit, parking, and stop at signals. So based on that one, automatically we can develop a logical and mathematical model is created is created on the basis of that, and after that the car will work according to the logical model. So simply this is called as a machine learning. So here the data is fed to more efficient output is produced, going to be produced. So you can define the machine learning in another way. So like a computer program is said to be learned from the experience E with respect to some class of task T and performance measures P. Measure if its performance at task T as measured by P and improves with experience E. So simply this is called as a machine learning. So that means learn from the experience. It's learn when the machine learning going to be learn from the experience with respect to some class of task T and performance measure P. And if its performance at a task T, at a particular task T, it is measured by P. It depends on the by using the experience. So we have a well-defined well-defined learning problem. For this, we are having three features. So the first feature is the class of task, the measure of performance to be improved, the source of experience. So here, for any learning system, this is a simple learning process. So here the machine learning is simply a learning process. For any learning system, you must know three elements. The first element is task, the performance measure P, and experience E. At a high level, the process of learning system is is the major things. Okay. So here for example, our target function is f of x, y, x comma x implies y. So here x is nothing but a corresponding features of the problem, and y is nothing but a corresponding target function. Okay, so here the training examples are like x1 comma y1, x2 comma x2 comma y2, and so on xn comma yn. So based on this data is going to given for the learning algorithm. So now we are going to give the new hypothesis data. For this new hypothesis data, our mission is going to predict the final hypothesis. This is the called as a learning algorithm. Now the learning process starts with task T, performance measure P, and training experience E. The our objective is find the unknown target function. Our aim is to find the unknown target function. So the target function is exact knowledge to be learned from the training experience and its unknown values. Is called as a target function. So, for example, in case of credit approval system, the learning system will have customer application records as an experience, and the task could be classify whether the given customer application is to be eligible for the loan or not. This is called as a task. So, in this case, training examples can be represented in the form of x1, y1, x2, y2, xn, yn, where x is represented as a customer application details, the customer features like customer name, customer record number, application number, all the customer from salary, customer address, all those comes under the customer application details. Those are called as a features of the customer. And y represent the status of the credit approval, yes or no, whether we can approve the credit or not. So here it like the data set is like a this one. So it contains two parts, x and y. So x is nothing but x1, x2, x3, and so on are there, and corresponding features are there. Okay, corresponding feature. So each and every feature contains a corresponding class label. So with these details, what is the exact knowledge to be learned from the training experience? So the target function to be learned in the credit approval learning system is mapping the function f of f implies x to y, mapping function x to y. So this is the your mapping function. This function represents the exact knowledge defining the relationship between the input variable and corresponding output variable. So the learning system try to guess a hypothesis function h of x that approximate the unknown function. So A hypothesis is a function that best describes the target hypothesis set or space H is the collection of all the possible global legal hypotheses. This is the set. This is the set from the which the machine learning algorithm would determine the best possible ways which would be best described as the target function or the outputs. So the goal of the learning process is to find the final hypothesis that best approximates the unknown target function. So for example, here checkers game is there. So here a computer program that learns to play checkers might improve its performance as measured by its ability to win at the class of task involving playing the checkers games through experience obtained by playing the games against itself. So here the a checker game learning problem is like here the main task is playing the checkers. The performance measure P is percentage of games won against the opponents. Is the performance measures. Playing the checkers game mathematics task and playing the performance measure is won the game against the opponents is the performance, and training experience is the playing the practice games against itself is called as a experience. We'll see one more example. So a handwriting recognized learning problem. So here the task T is recognizing and classifying the handwritten words within the images. The task is recognizing and classifying the handwritten words within the images. That is the main task. And performance measure P is percentage of words correctly classified is called as a performance measure P. And training experience is a database of a handwritten words within the given classification is called as a training experience. Now, a robot driving, one more example, that is a robot driving learning problem. So here the task is driving on public 4-lane highway using the vision sensors. What the problem here? Driving a driving a car, a robot car on the public 4-lane highways using the vision sensor. That is the task. And performance measure P is average distance traveled before an error. So before an error occurred, how much the distance is traveled is called as a measure, performance measure P. And the training experience is a sequence of images and streaming commands recorded while observing the human driver. So these are some of the examples of the machine learning. Now we'll see what is the process of machine learning. So here the major thing is the training data. The training data contains features and corresponding class label. So for each and every feature there is a corresponding class label. So this is the given for the your training your machine. So here our machine is going to learn based on this training data. So now based on this one, the model is going to be developed. The model is going to be developed. Our model is developed based on the training data. For this model, whenever we are giving the feature, new data, new instant or new features, so based on the training model, our machine is going to predict the new corresponding output. If the corresponding output is exactly good output, then we can stop the process. Otherwise, we are going to once again train your model and update your database, update the training data and once again train your model, and we get a new model. For this new model, our once again we have to provide the new data. From this model, the model is going to predict the corresponding output. So this process is repeated until we get the corresponding output successfully. So this is the machine learning. Thank you.